Right, the next type of inequalities we're going to look at is quadratic inequalities. Now, if it's a quadratic inequality, we know we have a solution set. So we have two values for x, which our solution set lies either between or it's the other side of it. Okay, so when I say the other side, we look at that in a little bit more detail as we go through the example. Okay, so step one, we call this our test box. Okay, so we have 2x squared minus 7x minus 3 greater or equal to 0. And you'll see why it's called the test box when we come towards the end of the question. So we'll call that our test box. Okay, so we want to solve this like we would a normal quadratic trinomial. We can't solve this using normal factorization, so we actually have to use the minus b formula here. Okay, so we have minus b plus or minus the square root of b squared minus 4ac all over 2 times a. And in this particular question, a is 2, b is equal to minus 7, and c is equal to minus 3. So we sub these values then into our minus b formula. So we have minus 7 plus or minus the square root minus 7 squared minus 4 times 2 times minus 3 all over 2 times 2. Now, when we put this into our calculator, the two possible values that you end up with is that x equals 7 minus the square root of 73 over 4, or that x equals 7 plus the square root of 73 over 4. Now, if we simplify that or change it to a decimal, then x is roughly about minus 0.39 rounded, and it's roughly approximately 3.89 rounded. Okay, now let's go back to when I said we had the test box and the fact that we know we have two possible values of x, but this is a solution set, okay, because there are a number of different values that will work for this solution set. But we don't know, is the solution set that the x values are less than minus 0.39? Are they greater than minus 0.39? And the same on this side. Are the values less than 3.89 or are they greater than 3.89? So we have to use our test box to test the solution set. So what we do is we break it up into 3 regions. So we call the regions are our test regions, and we're using our test box. So first of all, so we have x equals minus 0.39 and x equals 3.89. So we want to test the values for when x is less than minus 0.39, because we know that x equals minus 0.39 and we know x equals 3.89. But as there's a number of different solutions that will work for this inequality, we need to test to see is the solution set less than minus 0.39 or greater than 3.89, or does it lie somewhere in between here. Okay, so we test for a value less than minus 0.39, we test for a value that lies in between these two figures, and then we test for a value that's greater than 3.89, and that will give me my solution set. So we'll break it up into 3 regions. Okay, so for here, we pick a value that's less than minus 0.39. For this region here, we pick a value that lies between these two figures, and for this region here, we pick a value that's greater than 3.89. So let's pick a value that's less than minus 0.39. So if we go with x equals minus 1, because minus 1 is less than minus 0.39, and we sub the value for x into our test box, okay, and this is why this is called our test box, because we use it for our test region. So we're going to have 2 bracket minus 1 squared minus 7 times minus 1 minus 3, and we want to test, is this expression greater or equal to 0? Now if you put that into your calculator, that will give you 6. Now 6 is greater or equal to 0, so we would say that that region tests positive. So now we know that our solution set for one side of our inequality is that x is less than or equal to minus 0.39. Okay, and it will work for any value. If you check x equals minus 2, you should get that this value will be greater than 0. So we know then part of our solution set is less than minus 0.39. Now we want to test it for this region here. So we pick a value between minus 0.39 and 3.89. If we pick 0, 0 is the simplest because we know it lies somewhere in between there. And again, sub it into our original equation. So we have 2 bracket 0 squared minus 7 bracket 0 minus 3. And we test to see, is this expression here greater or equal to 0? Now, when you put that in your calculator, you'll end up with minus 3. Now, we know that minus 3 is not greater than equal to 0 because it's less than 0. So, therefore, that region does not work. So, our solution set will not lie between this number and this number. So, there will be no possible values between this number and this number that will work for this particular given inequality. So, we want to check for the last region. So, this time we pick a value that's greater than 3.89. So, if you pick x equals 4. You can pick any value, x equals 5, 6, whichever you want, okay? But generally go with the lowest one. So then sub it into our inequality. So we're going to have 2 times 4 squared minus 7 times 4 minus 3. And we want to test to see if this expression is greater or equal to 0. Now when you put that into your calculator, you'll get 1. And 1 is greater or equal to 0. So that particular region works. So then we know that our other solution set is going to be x is greater or equal to 3.89. Because remember, we already know that x equals this, but we want to check to see, is it less than or greater than minus 0.39, and is it less than or greater than 3.89. So we now have our solution set. So if we write it as one inequality, so we have x is less than or equal to minus 0.39, and then x is greater than or equal to 3.89. Now, say for example, you were asked then to plot that in a number line, and we know it's a real number, so we're using rows. Okay, so if we have 0, 1, 2, 3, 4, 5, 6, and so on, minus 1, minus 2, minus 3, and so on. Right, 3.89 is somewhere around here, and we know it is equal to 3.89, but it's equal to or greater than. Okay, so it would be all the numbers greater than 3.89. If you sub any value greater than 3.89 into our test box, the inequality would be true. Okay, now it's less than or equal to minus 3.89. So minus 3.89 is somewhere around here. Okay, and we know it's equal to minus 3.89, but it's less than or equal to. So it'll be all the values in that direction. So if you try to sub in any values between minus 0.39 and 3.89, they won't work for the given inequality. So our solution set for this particular inequality is x greater than or equal to 3.89 and less than or equal to minus 0.39.